All right, we'll go ahead and kick this off. Tonight we're doing programming for beginners. We'll be using Visual Studio to write C# using the .NET framework. If you're not familiar with Visual Studio, you can go to visualstudio.com and it will take you to this page that you can see right now. There are several different options. There's Visual Studio Code, Visual Studio, and Visual Studio for Mac if you're on a Mac. Code will work anywhere, Linux, Windows, Mac OS. For tonight, we're going to be using Visual Studio for Windows. You can use the Community Edition for free, especially while you're learning. It will be fully featured and able to do everything that we're doing here tonight. If you aren't able to follow along and don't already have this installed, you can download or watch the video later on YouTube or Twitch. It will be available after the stream, shortly after the stream. If you didn't realize, Visual Studio is a Microsoft tool. It's the best IDE I've ever used, and I've used quite a few. So let's flip over to here, to Visual Studio. So this is the screen you should get after you've installed Visual Studio. I'm going to pop this open. If you're installing for the first time, you will get a screen that looks something like this, with several different options. For this lesson, we only need, let's see here, what do we need? We don't really need any of this. You could check the .NET Core cross-platform development if you like. Console, we're going to be working with a console application tonight. We're not going to be using any UIs or web or Azure or anything like that, so you don't need any of these other things. But be sure to check them out later. All right, so let's flip over here to Visual Studio. Start at the beginning. All right, so you should have, once you have it installed and everything selected, it might take a bit. You can create, oh, let's turn that off. Exit. You'll get the screen here. There's several options that you can start off with. This side will be empty. You won't have any recent projects. So we'll want to click Create a New Project to start with a project template. And you shouldn't have any recent project templates here either. So we're going to search over here for a project. You probably won't have so many options. So we're just going to type in console. And it will give you a basic console application for these different languages. The one we want to choose is the console application. So go ahead and select that and hit next. And then we're going to name it programming.beginners. And then we'll get the option to select a target framework. I'm going to select .NET 5.0, which is the current release. We don't want to choose .NET Core right now. Those are a bit older. We're going to go with 5.0. So I'm going to click Create. And we should have a new project here. Now I'm going to go over the, let's adjust the font size here real quick. Fonts. Oh, it's up here. Now everything should be a little bigger and easier to read, hopefully. Okay. So we have over here on our right, this is our Solution Explorer. This is where we'll have all our files and all of our settings. For now, we only have one project. This is our console project. There is an XML definition file for this project, but we can also right-click it, select properties, and these are all the different properties. As you can see here, I've got my target framework, and I can select different ones or install more. I've got my output type, which is a console application. Startup object. We don't need to set it because it will default. We can do things like set the icon and do some more low-level stuff like setting the build and packages and signing and things like that. But we won't need to worry about that for this session. So let's close that. Now all our coding for tonight will be in the program.cs folder. So CS stands for C#. All right. So I'm just going to get rid of all that boilerplate code. You don't need it right now. It's not important. We will get to it eventually, but for now we don't need it. Let's start off with something basic. So in C#, to access libraries, we have to access what are called namespaces, and that's sort of a grouping of code that we'll get into more detail later. But for now, we're going to do using system semicolon. So anytime we end a line, we want to end it in a semicolon. That it tells the program that that's the end of the line. There are some things that you will want to do a line break, even though you're not ending your code line, just so that it's easier to see on the screen. And the semicolon will tell the compiler that's the end of that statement. And in programming, there are variables. Variables, if you've done algebra, they're like X and Y and Z. I like to think of them as post-it notes. So I can get a post-it note, and when I define a variable, I can call it X. You can call it anything you want as long as it is alphabetical, underscore, or numbers. You can name it anything you want. So let's name it variable 1. Don't use this naming for your program, but that's just an example. You use something that's meaningful to tell you what it is. Okay, so this is me defining a variable, and this is important in programming because I'm telling it two things. A, I'm telling it is an integer. An integer is a number. It doesn't have a decimal. It's just a simple 8-byte number. And or actually 32 byte. I don't know. That's not important. We'll get to things like max int and things like that. And then it's telling it that we need to address a place in memory. So there are things called pointers, which are more advanced, and that is sort of like a bookmark in memory to where your variables are. And so your program kind of keeps track of all that. Your compiler does that for you. You don't have to really worry about that in C#. So we've created our variable. Now we can do something called assigning it. So we're going to assign it a value. If I don't assign it a value, it's going to be its default, which I believe is 0, but let's test that out. Okay. To output, we're going to do this console.writeLine, and we're going to put variable 1 in there. And I will explain this for a little bit later. Just go ahead and write that in there, and that'll output it to our screen. So we've got variable 1 equals default int, and we're going to run it. And so it's a little small. I wonder if I can make this bigger. Will this work? There we go. Let's see if it remembers these settings. But you can see that that's a 0, so that's the default int. If I don't assign anything to this, it'll be a 0, but it's going to throw an error because you have to assign a local value, a value. But in other cases where it's not a local variable, it'll be a 0. All right, so the next thing, there are other types. These are called simple types. There's double, float. So if you want to do like decimals, I would suggest using like a double. If you want a smaller integer, you do a short. If you have a really long number, you can do long. Those are the numbers. Then there are things like bool. So bool is a Boolean, which is true or false, right? Those will be important for condition statements and flags. You can do byte. And those are the primary simple types you'll be using. There's also a thing called a string. And you probably see a string quite a bit. Call it variable 1 again. Hello, internet. Let's do stream. Hello, stream. I need my semicolon. It makes red angry squiggles here. You see the red little squiggle down here when I don't do something right. So I like to say I like to slay the red squiggles. So I forgot to put my semicolon there, and I put it there, and now it's fine. And I'm going to run this. So we've got a variable called hello stream. Let's see if we can make this a little bigger. Well, we don't want to do 72. Okay. There we go. So hello stream. And again, I did that a little too quickly. So you can see that I'm outputting my string here. Something to keep in mind with strings is that anytime I modify a string, so I'm creating a new copy of the string with the modified version. So if you want to keep track of your memory issues, you want to use something like string builder, and we'll get into that in a little bit. So let's get into operators. Operators are ways of modifying variables, right? So if I want to add x to y, I simply do a plus, just like you would do in math, and then it will output it. And I got 3, which is 2 plus 1. If I want to subtract it, obviously I'll get a -1 here. You can do multiplication. You can do what's called a mod. So if I have, say, 10, and I do mod of 3, it's going to give me the remainder. So basically it divides 10 by 3, but the result is the remainder instead of how many times it divides into it. So I get a 1, which is the remainder of 10 divided by 3. There are bit operators that you can do as well. We won't get into that right now. That's a lot more complicated math than I want to cover. There are operators for Booleans. True Boolean. So we can do things like and or. So basically I'm doing a true, if true and false is true, then that would be the result. But this is going to be a false. And then I can change that to true, and then this would be true. Okay. We can get into more complex types. There are structs, and there are classes. And classes is what you're going to see mostly. So we can define a class as, so going back to the post-it note, a variable is sort of a post-it note. And I know what size the variable is going to be because I said that it's a yellow post-it note. And a yellow post-it note is only so big, and that's how much data I can put into it. Well, a class is more like a definition of a type. So I can say a dog, class dog, and I can say it has feet 4, right? And then I can say it has a nose of 1. And then I could do the same thing with structs as well. I can use set what are called fields. These are fields. You can't define them in there like that, but class is defining a type. It's sort of this is what dogs are like, right? If we could do other things like coat color, so the color of the dog's coat, right? And then I can actually create an instance of the class. Oh, noted. Okay, so we're going to put the class below the console for this example. So if I want to create a dog, and it's a particular dog, I would say dog Sasha equals new dog. And then I can output Sasha. Now all classes inherit from what's called object. So these are complex types. And even if I say that it is an object, it's an object. So once I've created this class, the fields are by default what are called private. And that means that I can't access them outside of inside this class. So if I wanted to change the coat color, I can't do that. However, I can do something called public. And now that is a public field that anything can edit. And I can say that she is blonde, blonde dog. And if I want to, I can output that color. And she is blonde. Now, I can also create a dog named Tanya. Now these are 2 separate instances of dog. And when I set Tanya's coat color to black, it doesn't change Sasha's coat color. It's its own separate instance. So I'm going to say Tanya, I'm going to output Sasha's coat color and Tanya's coat color. So blonde and black. Now, if I wanted to do something like trying to think of something for this example. If I wanted to share a field across all instances of dog, I would do something called static. Let's call it feet. No, let's not call it feet. Let's just call it x. Int x equals 1. Okay, so there is only one posted note for x, while there is a posted note for each instance of dog for coat color. And when you change one, you don't change the other. So if I say x Sasha dot x, I can't change it here, but I can change it at dog. So all dogs have x of 4. Or we could, play on the go to all dogs go to heaven. Maybe? No? All right. So the other thing that we can do to modify these fields is something called read only. And a read only means that it can't be changed. So I can't change coat color ever. It's always going to be blonde or it's always going to be black. Okay, and it tells me that at the compile time that I can't change that that field, so I can't even run it. So in order to actually set this, we can do something called a constructor, and a constructor is basically this little thing right here that is called once when we new up an object or instantiate an object, and we can provide it values. And we'll get into defining methods and things like that in a second. But this is called a constructor. No, this is actually prototyping it basically. If you're wondering, VBAGs. You don't need a .h file if that's what you mean. So this is the constructor, and inside the constructor we can set read only. But because I've named these the same things, we have to tell the program which coat color I want to set. And whenever I have a local variable and a class level variable, it's going to use the local one, the closer one to wherever level it's at. So I have to tell it this, which is this object, so this one ties to this field, and then coat color, which will default to the local version or the local variable. So now I'm telling what this value is. And so I'm going to have to get rid of these, but I'm going to put it in the constructor. So this is me calling the constructor right here, dog, and I'm passing in the variable black for the coat color. And now I've instantiated the coat color to blonde and the coat color to black by using a constructor. And I cannot change it later. It will give me an error, but it will set it, as you can see right here, blonde and black, right? All right, so this is great. We can set variables, but we want to actually do something. So in order to tell the program to do something, we have to tell it. We have to be very specific. The thing about computers is a little secret I'm going to let you in on. They're dumb. You have to tell them every little thing that you want them to do. Down to the pixel. Now, fortunately, there's some really smart people that came along and wrote a lot of this stuff for us, so we don't have to draw out the pixels to draw the D and the O and the G or whatever. We just have to create this, write this text instead of having to write like binary or assembly. We can write this text and it will compile it down to assembly. Well, actually, C# compiles down to IML, which is run at runtime into assembly, but that's probably a lot farther you want to go right today. So we have to do functions to make it do something, whether we want to execute something, do an operator, or whatever. So we're going to create a function. We're going to make it public so anybody can access it. And then we're going to say it's not going to return anything. We're just going to do something. We're going to bark, okay? Because all dogs bark, at some point, hopefully. And we're going to have it right to the screen when it barks, okay? So we're going to say roof, okay? So I'm going to say Sasha.bark. So this is me calling my method, okay? And we're going to see that it says roof. So right there, roof. Rough, rough. All right, so we're barking. All right, so what else do dogs do? Dogs will walk. And we're going to say distance. So this is called a parameter in a method. So inside the parentheses, we define parameters for a method, and we can have more than one. And then we pass that in when we call it, and then when we get into the body of the method where we do the work, right? That's when we use these variables. Now, something to keep in mind, there's different types of ways of passing in variables. There are variable or parameters that are by reference and by value. So let's come down here. Sasha dot walk. Oh, let's create a little variable. Distance. Let's go 5. Let's just say 5 feet, and then speed 1, whatever speed 1 is, and then we're going to pass that into this method. Now we're going to ignore speed here for a second, because we're not going to get into anything like threading or anything crazy tonight. But we can do. Well, let's change it. So what happens if we set speed to 2 when we call that, and then we're going to output distance and speed. What do you think will happen? Anybody want to guess? You can put it in the chat or the comments. No? Okay. Well, let's run it and find out. So it stays the same. It's 1, right? So it's being passed as value. Basically, what we do when we pass by value, we create a new post-it note, put the same value on it, and then pass it over to this method or function. And so anything I do to speed inside the method is not going to affect speed up here. Now, if I wanted to do, let's see here, am I doing that right? No. Yeah, if I say ref, that means by reference. I'm overriding the default. Oops. Oh yeah, I have to tell ref up here as well. It gets upset. It gets a little feisty. Now it's setting it to 2, so it's by reference. So instead of copying the posted note, I'm just passing the note, and it affects that change. There is also something called out time. So say we wanted to calculate how long it took, we could pass an out variable. Did I do that wrong? What are we complaining about? Oh yeah. So I can say out, and it will pass it back to where it was called as a new variable. And we're going to say time equals distance divided by speed. Okay. And I'm not too terribly fond of this this way of passing in and out variables, um, simply because it's kind of ugly. And I can console outright line time. Oh, put that to 1 again, or don't set that. Don't set that. So we have 5 divided by 1 is 5. That's our time. So we're outputting time. I don't like that if we're just returning one variable. There is what's called a return type, and we're going to go back to this void right here, and we're going to replace it with int. So this is telling the method definition or the method signature that this method returns an integer. In this case, we're going to return distance divided by speed. And so when we call the method, we can place it in a new variable or an existing variable by assigning it to a variable. So we call walk and we assign it to time, and it'll output it there. And we're at 5 again. Okay. And there's some other things that we can do in here. The other thing that we can do is we can have a default value. If we want to say have a default value, so we assume that speed is 1 if we don't pass it. If we don't have a default value and we don't pass speed, it's not going to compile, so it's not even going to let us run. So we'd have to have speed. So let's get rid of it again. We'll give it a default again. So if I don't provide speed, it's 1, but I can provide speed. So say my dog is running faster, I can say 2 instead of 1, and my time is 2. Now that's rounding down. We're doing an integer division. There's no rounding on it. If we wanted to have a decimal, we would want to use a double. So that's default values for methods. If we were to pass something a little more complex, we could define, say, a class of velocity. Which is direction and speed. So we get rid of the speed, and now we have velocity. And we can access this field by doing a dot and then the name of the field. Now this is going to throw an error up here because we have to create a velocity variable. Oops, if I learn how to spell, right? So I have to create a new velocity, and I'm going to assign speed of 1. Well, let's assign it speed. No, let's not. Let's get rid of speed. All right, so I created a new variable called speed. It is a complex type of class velocity. I assign speed of 2, and then I pass it into walk. Now, you remember reference versus pass by value. This is a complex type. So if I was to say velocity dot speed equals 3, what do you think would happen? Anybody want to take a guess? Everybody want to be quiet and not say anything? I know you're there. Well, let's find out. I'm going to run it, and we'll see what happens. So distance is 5. The velocity speed is 3, so it changed it. So by default, when you pass an object in, it will pass by reference. So we're passing the same post-it note in. We're not copying it. And there are advantages and disadvantages to that. And there's some philosophies. There's something called functional programming, where you want to pass everything by value, and you do not want to edit the original value. And that's really great as long as you're consistent. You don't want to do functional programming in some places and not others in the same program, because it gets confusing. And so that is methods and fields. There is something called properties. Property is sort of like a field, but it's a little more defined. It has a getter and a setter, which allows you to define functionality around getting and setting. So whenever you get it, this is a get, and this would be a set. So you set the speed, and then you get the speed from velocity. And right now, this is functioning very much like this. Okay. There's no real perceivable difference between these two, except that this is a property and that has a getter and setter. Now I could do something like this, which would mean that nothing. Why is it doing this? Build. Oh, well, you shouldn't. Well, shouldn't be able to set this, but because we're using basically internal classes, it's not working. We'll discuss that later. So you can do a get, and we're going to return what's called a backing field. So we want a private backing field. So nothing's supposed to be able to access this private field, right? Okay. And so if I want to control how the get works, then I can create a get around it with a property. And then when I set it, I'm going to get something called a value. And I'm going to assign value to my backing field. Now this seems like a lot of code to do the same thing that we were just doing. But some of the really cool things you can do with it is, say you had a cache and you didn't want to have to do like a database lookup or something, then you can have it pull it out of like a cache or something like that. Or if you wanted some kind of validation around it, like or something to change as a result of the property change. So say speed changed, right, due to some calculation from direction, that you could have speed change whenever you set the direction. Or you could have some event that triggers, and that's some really neat stuff you can do. That you could have an event trigger whenever somebody sets direction. So you can put some basic logic in around these. I wouldn't put too heavily logic. If you wanted to do something that's a lot more complicated, like a database call or something like that, you should put that in a method, especially if it's going to take time to come back. You want to put that in a method. HTTP calls, that sort of thing. You put it in a method, not a property. All right, so we're gonna start all over. We're gonna delete all of this. So I'm gonna put my using in here, system back, so I can output to the screen. And then we're gonna create something called a namespace. A namespace is a grouping of code that can go across libraries or DLLs that we reference into our program using this using right here. So if I had namespace system, then I would reference it with using system. But we don't need to reference the namespace from within itself, because that's circular logic and it gets messy. So we have namespace. So anytime we want to access any of the code that I put in this namespace, I'm going to do a using. And then I'm going to create a class. So anytime you want to create a console application, the default thing is this is going to have a class. And the default method it's going to reference is the static void main. And then anything I'm going to execute in here will be what happens at runtime. Hello stream. And what I was doing earlier, Visual Studio puts all this boilerplate code around it. I don't have to do it myself. But for this next example, I want to put this all back. Okay. Let's go ahead and run this and make sure it's still working. Hello stream. There we are. Is anybody out there? Hello. Hello. I see you. Okay. So we have this. And like I mentioned earlier, if I wanted what was it? Velocity? Class velocity, right? Hello. No, that's right. And I wanted to create a property of direction for the private setter. This should work now. Watch it not work. Awesome.
Mic off. Mic on.
So I can go ahead and set direction. I shouldn't be able to set direction. It should throw an error. Yep. Okay. So there we go. I wasn't crazy. Because it's private, I can't set it. So if I get rid of this, I can now set it. There is another accessor. These are called accessors: public, private, internal. So internal means that anything in the same library or application can access it. So if it's in the same DLL, it should be able to access it. So if I was to create another program and reference velocity, I couldn't set it. That's not something you typically want to use. So let's talk a little bit about inheritance. So C# is an object-oriented programming language. So we focus on objects, types, that sort of thing. And in an object-oriented language, we have something called inheritance. And inheritance means that we can have base classes. So I have a class of animal, right? And then I have a public class of mammal. And then there are certain inherent things to animals and mammals. And if I wanted to have everything that's in animal, methods, fields, all that sort of thing, I would have to either copy it, which in programming language, that seems silly to copy. We should just be able to reference it. And then the way we do that with object-oriented programming, instead of doing like a link, we do something called inheritance. So this basically says that I have access to everything in animal. Now, we never want to instantiate something that's just an animal, right? So we're going to call it an abstract class. So now I can't do animal because there's things that need to be implemented um, inside animal that you can't know, like how does an animal walk or swim or whatever or move, right? Those need to be further in here, and they will work differently in different kinds of animals because fish swim and dogs walk and birds fly, and they're all animals, right? So we'll have a virtual method, no, an abstract method, void move, right? And now it's complaining because I made this an abstract class. This means that mammal has to implement it. So I have to have move. Or I can make mammal an abstract class too. And there's subspecies and all that. We're not going to get into all the biology, but we're going to have a dog, and it's going to be a mammal. So anything that's in mammal is now going to be in dog. So if we had things like, it's something that all animals do. Well, mammals breathe. So do all animals breathe? I suppose they do somehow. So we have public abstract void breathe. Okay. And mammals, they all breathe air. So we would do something abstract like, well, we wouldn't do something abstract. We'd do something specific like take in air. This system isn't that complicated. So we take in air. Why are we angry about this? I'll figure that out later. So we have to implement, oh, let's see here. To override? Yes, I need to override. Breathe. Breathe, Sean, breathe. And then I implemented breathe in mammal, and so I'm going to be able to access that inside a dog. I don't have to rewrite this. It's already done. But because I'm an animal, I know I have to move and breathe. Breathe's already done for me, but a dog has to move, right? So we're going to implement move. I know this isn't really moving, but whatever. Walk. Dot, dot, dot. We're going to change this to intake oxygen, because from air, because fish breathe it from the water. Okay, intake oxygen from air, walk on 4 legs. Yep, hopefully. So we've defined these different methods. You can do the same thing with properties as well as you can have abstract properties. You can have abstract fields. Okay. The other thing now to be a truly object-oriented language, you have to do be able to do something called multiple inheritance. So technically, I could inherit from multiple classes. So if I had a class called 4 legs, right? Oops. I cannot spell tonight. To be truly object-oriented, I'd have to be able to do multiple inheritance. That means I can inherit from multiple classes. Unfortunately, you can't do that in C#. So it's not truly an object-oriented programming in the sense of, by the book. We do have something called an interface, and I'll cover that in a minute. So let's just actually implement this. So we want a dog because dogs are awesome, and we want our dog to breathe because that's important, and we want our dog to walk. What? Oh, move. Sorry, move. So we should see intake oxygen from air, walk on four legs, hello stream. Now, if we wanted to make breathe work slightly different in dog, we can do what's called an override. And this override will change how breathe works from this. This won't happen. So if I got rid of this, it would do nothing, which would be kind of bad because you want to be able to breathe. Breathe through mouth, right? So now instead of intake oxygen, I have breathe through mouth. There might be some instances where you want to still do the base class behavior. That's this mammal. Mammal is the base class of dog because dog inherits from mammal. Dog is considered the superclass. I don't really hear that term in C# so much. I hear that a lot in Java, but dog is the inheriting class from mammal. So base.breathe will execute whatever the base is. Can I do that? If I wanted to execute animals breathe, I could do that. But this inherits the last implemented breathe from its ancestor class or base class. So I get intake oxygen. Oops. Intake oxygen from air, breathe through mouth. Are there any questions? I know I'm kind of going fast. And you feel free to ask in the chat / comment. All right. So in order to be somewhat multi-inheritance, there is a thing called an interface. And that is a contract in programming terms that says all of what a inheriting class has to implement. So if I was to have animal, I have to implement move, I have to implement breathe. I cannot put fields in this. I can put properties. So I could have a property of legs. And I could get rid of the set and implement the set in the class. But animals don't necessarily have legs. Fish don't. Mostly. Most fish don't. I'm sure there's a fish that has legs. So if I was to implement animal, then I have to implement anything defined inside the interface. And you may have noticed I got rid of public. Public is there by default. You can still leave it in there, but you cannot have a private method from an interface because how would you ever call this? You can't have code. You can't implement methods inside of an interface. You can't execute code. So you would never be able to call move inside of an interface. So you can get rid of the private. Well, you have to get rid of the private. You can get rid of the public. That's optional. And typically interfaces are called I. They have an I before the name. And anything that when instead of calling it inheritance or inherit, we use implement. So mammal implements I animal. And even though it's an abstract class, I still have to define move. But I can make it abstract. Um, and you may notice that when I got rid of the override and made this an interface, I broke breathe. In order to override a method, I have to say it's virtual. So any method, any normal method that I'm not overriding already has to be virtual if I want to override it at an inherited class. So if I don't want anybody to ever be able to change breathe, I just make it a plain public void, and any inheriting class cannot change how breathe works. So we want to make this virtual so we can override how it behaves. So it is what's called a virtual method. Okay, let's delete all this. All right. Whew. Getting a little sleepy here. So a class can implement multiple interfaces so let's talk a little bit about that. I'm trying to think of a good example. All right, so let's do student. And let's say that the student is a person and a contact. So let's define what a person is. So a person has a name. And let's say a contact has an address. And let's say we have a method called call. So we want to call the person. A contact in this case may not necessarily have a name. Well, okay, let's back up a little bit. Let's say first name, last name. A contact may not always have a first name and a last name because it could be a business, right? So now we have to implement these four things. There is little squigglies here, so we can cheat a little bit. If I hold the control button, hit the period, it will pop up with this little menu that gives me suggestions on how to fix this. And I'm going to say implement method or property, implement members. So I got that fixed. And by default, it's going to throw an exception if I try to access it, and that's really not the functionality we want. We want to be able to use the property without the application crashing. And then we need a string address for student. Oop. And then we want to implement void call Now I'm going to do something where I concatenate or add with the plus operator two strings. So this is a string and that's a string. So I'm adding that, and it'll output both of those combined. So I can have something like iPerson, and I can assign it a new student. And there's this quick little shortcut. Instead of having to say person dot first name, person dot last name, I can do an assigner with my constructor. Probably should add phone number. Well, we would, but we're not doing that. Address 1234 Nowhere Lane. Right? Now, I've defined this variable right here as an iPerson. So it's only going to let me access whatever is available to person. So I can say plus person dot last name or first name, but it's not aware of everything that student can do. So hello, Sean. Now I could change this to student, and then I could do person.call. And say we see ringing Sean. Or I can say I contact. Now it no longer knows what person is, so we're going to do something called commenting out. I do double slash, and that'll no longer be executed. But it's still aware of what call is because iContact has a call, right? So it's still ringing Sean. Now, if I wanted to change it to add a class business, so this is saying that I'm going to implement. I'm making a contract, not a contact, a contract to implement everything in iContact by implementing or inheriting from iContact. Let's do something different. We'll do ringing address. Now, if I did business here, it's not going to like first name, last name, so we'll get rid of that. I don't have to change this, right? I can still call it. And it's going to do ring address. And I don't have to change this. I don't have to say calling business. And that can be useful. Let's back up a little bit. There is this thing called an array, which is another variable type. And instead of having one instance, we're going to have multiple. So if I wanted to have 3 ints, I could do an array. So I use these little brackets to indicate that this is an array. And you can name it whatever you want for the variable name. And then I'm going to say new int, and then I'm going to tell it how many I want. Okay. And then I can define what those values are. Okay. So this is an array in a nutshell. But I don't have to be limited to int. So this is something else I could do, is I could have an array of contacts. New I contact 2. And because I said it's a contact, I can say new business, right? and new student. Now, we're going to call this array contacts instead. Okay, so now we have a bunch of contacts, and say this is our address book, right? In order to get through them, we have to do something called a loop. A loop is executing the same code over and over again until a condition is met. So the most basic type of loop is a while. So we're going to do execute code while this is true. Now you never want to do while is true because that'll go on forever and ever and your code will never end. So you want to do something like index is less than 1. But the next one, and it's used a lot for arrays, is a for loop. And there are 3 statements in the beginning of a for loop. First, we're going to define our variable. And we're going to set a condition to when we're going to stop. So we want to do 2 times, but we might end up adding contacts at some point. So it won't always be 2 contacts. Hopefully we'll add to our contact list, our address book. So we're going to do contacts.length. And this just tells me how many items are in the array. So length is how many items are in an array. And then we're going to increment. So this is our increment. And there's a lot of different things we could do. We could like reverse it where we start the index at length and then go to 0 and then subtract each time. You don't have to follow this. Some people get confused that this is set in stone. This is how it works. It's not. You can change these statements up. Each individual segments are just statements. They're code themselves. So since they're contacts, in order to each access an item in the contact, we use what's called an accessor. You can actually have different kinds of accessors. You can do int or different variable types. In this case, because it's an array, it's just an int accessor. So we're going to say iContact equals contact. So this is saying the index, which will be 0 and then 1. So the 0 place in the contacts and arrays. And programming always starts with 0. You know how most people go 1, 2, 3, 4. Programmers go 0, 1, 2, 3, 4. Or 0, 1, 2, 3, rather. And then we can call the method call. So if we want to call everybody in our address book, hopefully we won't do that. That would be kind of bad. We can call it call, and then we ring address. So we are, let's see here. Ring address. This is executing the business implementation of call. And this here is implementing or executing the student implementation of call. Instead. And that's one of the great things about contracts or interfaces is that we can implement the methods differently based off of what it needs to do. A better example might be that you have like a business phone or not a business phone. You have a home phone or a cell phone for a student. You call the cell phone first, and for a business you would call the work phone instead, or something like that. And that is interfaces in a nutshell. And that is all we have for tonight. Are there any questions that anybody has about what we've covered so far? No? If you want to reach me um, after this session, you can reach me by commenting on my YouTube video that'll be posted. You can comment on Facebook, or you can reach me on Twitter. It'll be accessible via pixelspark.tv. You can, yeah, those are the main ways to reach me. We will be back tomorrow with our mobile development from start to publish as I work my way through a mobile application, writing that. It will be a little bit, it'll be a lot more advanced than this, but you're welcome to join us. Hopefully you found this useful. If you did or enjoyed this, please like and subscribe. Um, and also check out our Patreon page if you're interested in more benefits and help support the channel. And I appreciate everybody who came to the live stream. Thank you all very much, and I will be seeing y'all. Toodaloo.